Hi, everybody. Let's start with a quick review. We'll go back to this guy, which was okay, so we left off with this guy. Where we started talking about a first derivative. So the first derivative number line is a way for us to organize our information, and so it also tells us quite a bit. If you recall the example that we did, we found critical numbers at 0 and 1. You put those on the first derivative number line. Two reasons why you must label this as the first derivative number line. Number one, because we'll have a second derivative number line soon, and you got to be able to tell the two apart. And number two, it tells you where to plug numbers into when you're testing regions. So let's say, for instance, I want to test this region here, and I put in -10. Where do I put in -10? F prime, not the original function. Put in 1/2. Where do I put in a 1/2? First derivative. Where do I put in a gabillion? First derivative. Okay. Test the regions, we find out where the function is increasing, decreasing, and increasing, which makes sense for this example because we had a cubic function. Okay, so what's happening at 0 and 1? Josh, what do you think? At
0.
Why? Convince us that that's a relative maximum.
Because that's the point where it goes from positive to negative.
What's it?
The graph.
The graph goes from positive to negative?
No,
Wait.
the tangent
The tangent.
line.
The
Slope.
the slope of the
Derivative?
the slope of the derivative?
No, that is the. I don't know.
You're there, you're just not using the correct words. I'm just not going to let you skate with using things like it or they or that.
Well,
Hold on, you think about it for a second. Do we all agree that 0 is a relative max?
Yeah.
Outstanding. You've sold us, now convince us. Ooh, almost got one in the chops. Convince us that that's a max.
because that's the point where it goes, where the slope is going from.
The slope of?
The thing.
When you're out in the sun too long, you get a nice slope of the tangent line. Good. Goes from,
Positive to negative.
okay, so why does that make it a max? By the way, everything you've said is 100% correct, but I'm still not convinced it would be a max because I'm stubborn.
Can't I just like phone a friend?
Sure.
Ken, why don't you take a try?
Kelly's got it.
What's the question? Like beyond like what you asked, like what, or like what else?
I just want somebody to convince me that 0 is actually a max. I believe it just like everybody else does, but how do you explain that it's got to be a max? Or if you prefer, why is 1 a min? Hmm?
I don't know. I didn't know it was got it.
But
I think I got it. So because it's increasing when x is less than 0, when it hits that critical number of 0 and it starts decreasing past it, you have to say that it's a maximum, since at 0, where x equals 0, it has to be the highest where it increased, since then it's going negative after 0.
how do we feel about that? Hold on. Beautiful.
For the first time in forever.
This is a situation that you could actually, and I don't mean to belittle anyone, but it's something that I could explain to someone fairly young. If you think about it, back to the whole Rolle's theorem thing we had, that if we have a function and it's going up, and then all of a sudden it hits a point and it goes downward, then that's got to be the top of the hill. You're walking up a hill, walking up a hill, walking up a hill, and now you're walking down the hill. I must have at some point hit the top. The same is true over here. I'm walking into a pit, I hit the bottom of the pit, then I walk out of the pit. At that point where I change from decreasing to increasing, it's got to be a min. So are we good? I mean, we all agreed that that's the case. Now we need to just clean it up a little bit, and to clean it up a little bit, we're going to use something called the first derivative test. The first derivative test will answer the question, why is that a maximum, or why is that a minimum? And it's pretty much just a sentence, and that'll do it for you. So we'll use this as an example. We've got a nice cubic here. It's nice and pretty.
Pretty cute.
It's got a max and a min, also known as relative extrema. And you can see where it's increasing, then decreasing, then increasing. Okay, so we want to take that idea and organize it into a first derivative test. This is the first derivative test. It's just a different way. This is the calculus speak that explains exactly what Vlad said before. Which also combines a little bit with what Yash said too, because now we're talking about f prime. F prime goes from positive to negative. The slope of the tangent line goes from positive to negative. It's got to roll over the top of that hill and give us a max. If the derivative goes from negative to positive, then it's going to roll over and give us that valley or that minimum value. Well, oh, hey, my viruses have been updated. Yeehaw! We'll talk about 3 in a second after I give you a chance to copy that down. The next question I have for you while you're writing is, what is 3 in English? What does that mean? Nick?
If it doesn't change from positive to negative, then
What's it again?
the slope of the tangent line.
Okay, the derivative, the slope of the tangent line. Good, good.
Then it's just like it's a straight line, or there's no relative or max and min.
Yeah, there's no extreme. If you're always going downhill, you can't have a max or a min. If you're always going uphill, you can't have a max or a min. That's all 3 takes into account. That there are certain chunks of graphs that we can look at that would neither have a max nor a min. Most of the stuff we're going to do, though, is going to involve with 1 and 2 there. Come on. There. If it goes up, then comes down, it's a max. If it goes down, then it comes up, it's a min. Go over the top of the hill, go down to the bottom of the valley. Okay, we good with the concept? By the way, we still haven't gotten to the first derivative test. That comes later.
Wait.
I wanted to point out one other thing. Notice critical numbers, just a refresher from Friday, they happen when the derivative equals 0 or when the derivative does not exist. Those are both important, especially when we start graphing critical functions. So we have to include things like asymptotes on the list of critical numbers. Now we good? All right, let's try one. Find the relative extrema of the function. So what do we do to find the extrema? Take the derivative.
Derivative and set it to 0.
Colin's got the, it's like, I was thinking of like Run DMC when one of the rappers would say something and the other one would say exactly what he just said right after. Like, take the derivative, take the derivative. Then what? Set equal to 0. Right, so now we're busting a rhyme here. Okay, then what, Noah? Buster love his early stuff.
Solve for x. Solve for x.
Solve for x. That would give us a critical number.
And then you
No, that would give us a critical number.
give us a critical.
Yeah, because I threw it back to you that time.
Yeah,
So you gotta, come on, you gotta stay up with us here.
Gotta
Then what do you
stay
do with the critical numbers, Noah?
Set it up, put on the number line.
Put it on a number line.
What do you label the number line now? You label the number line? F prime. F prime.
Testify, boys, keep going.
Then you determine if it's increasing or decreasing. Yeah.
Skip that wins right to yeah. Okay, so do it. Take the derivative, set it equal to 0, find the critical numbers, put them on a first derivative number line, test some regions. Remember, when testing regions, we don't care what the value is, we just care about the sign. Positive or negative. Are you missing something?
Sam just decided he needed to show up.
Oh, it is America. I can follow right now. You don't have to go to school, you just have to go and face the consequences. How many critical numbers did you get? Two. Bueno. And you can cheat a little bit too, because that's a cubic function. You all kind of know what a cubic function looks like. And it's a positive cubic function, so it's going to go like... Okay. Yeah, correct. So we should have two critical numbers, like you said. What are they? Negative 5 turds and 1. Oh, notice also, no weird critical numbers. There's no points on this graph where the derivative is undefined, because it's a nice, pretty polynomial. Okay, derivative, critical numbers, beautiful. Slap them on a number line. Test regions. What's it look like? Does it go minus, plus, minus, plus, minus, 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 plus, 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 minus, minus, plus, plus? No? No, you got it, Colin?
Plus minus plus.
Plus, minus, plus.
That'd be funny.
Okay. Question?
So when you plug in numbers, it's numbers into the derivative. Okay.
Yeah.
And then lesser, like in between the numbers.
Don't make the mistake that's fairly common is people will test the first region, get an answer, and then just alternate it all the way across the number line. That's bad. Don't do that.
Bad math.
Okay, bad math, correct. And also make sure you're testing a number that's actually in the number range. Okay? So don't test -1 over here. It happens all the time. You go wait, put in -20.
No.
You can, yeah. Because look, factored form. If I put in -20, don't look at the value. Look at the signs. If I put -20 in there, I'm going to get a negative number. -20 in there gives me a negative. A negative times a negative is positive. You're done. Plus, move on to the next region. What's a good number to put in the middle? 0 works really nice. Plug that in. You get negative. Negative times a positive is negative. Noah's got a question?
Yes, I think it's on the homework though. Like, if you get 2 of the same in a row, is it just
That could happen.
no?
Be patient, grasshopper.
Right.
Okay, you'll see. Took that into account for today. Just for you, buddy. Little shout out to you. Okay, so any problems with this? This is all, we didn't do anything new here, but now we got to do a little bit of first derivative. What does that tell you about -5 turds?
It's a max.
It's a max, and at 1,
Min.
it's a min. Okay. This is the new stuff. I know it's a whole big paragraph with some big words in there. Let me know if you need help with any of those words. Okay, good. They want sentences. I don't know why, but they like when math people write sentences. So this is going to be what we're going to consider the first derivative test. These are an explanation that justify why those things are mins and maxes. You need 3 things. Sorry, 3 things. Is it a max or a min? That's number 1. Where does it happen? Number 2. Why does it happen? Number 3. Okay. It's a relative min, number 1, that happens at x equals 1, number 2. And that's a min because f prime changes from negative to positive. Easy peasy? Good. Like I said, nothing new except we're doing what we did Friday and just throwing a sentence at the end of it.
Yes.
Neat.
Shut up, man.
You guys fighting again?
Yeah, you gave me dirty look.
Oh, God. Are you okay? You want me to go get the dog? Not the dirty look.
No, I handled it.
You did?
I handled
Okay,
it.
good, yeah.
Yeah, I told him to shut up.
Yeah, I know. Took the mature road on that one. Attaboy.
Say anything.
Right.
I was the bigger person there. Not literally, though.
Sure.
Figuratively.
Bigger.
Yeah. Who is a bigger person? No, are you taller than he is?
Yes,
Yeah. So he would always be the bigger
He's never
person.
the big. Colin's never the bigger person.
Cal-
Can
You
be.
know what you just got for.
Where's,
He's bigger than Billy, maybe. Jeff, how tall are you, Jeff?
like 5'1", 5'2"?
5'1". Colin, how tall are you?
5'3", 5'4".
Okay, there you go. So he's golden.
Bigger person.
Yeah. All right, let's put this into play.
Danny.
Do it. It's gonna be fun.
Make it a derivative. That's some dirty stuff.
Try to take this all the way to the end with the sentences. Connor and Tim ditching together.
Possibility.
I mean, that's true. Possibility of just about anything. If I would have said, was Tim turned into a bunny rabbit? It's a possibility. It's a possibility, sure.
So do you multiply these out to the key number?
Mi casa es su casa, senor.
Uh,
Now that you've had a couple seconds to work on that, how many are doing a product rule? Raise your hand. Anybody get saucy and distribute the x to the 1/3 in there? Okay, there you go. Either one. Whichever one works better for you.
I see you working, Danny.
Oh yeah, better.
Why you it's making me really like that?
Yeah.
Yes, stop.
oh, I know what you do.
Oh, no, I just gotta take out a 1/3.
Yep.
Actually, yeah, just you actually take out a negative 2/3.
Exactly. So then you get this.
I'm just gonna do this product rule. I'm gonna change. Yeah. Maybe. Who knows?
Well, you
Stranger things have happened, right?
I distributed them out.
That's the thing.
A little bit of practice too in factoring things out there.
So then I can just do this. I'm gonna get
What's negative 2/3?
Anybody have a derivative for me yet?
We're approaching.
Approaching? Okay.
Here, I'm getting this
Since most of you did a product rule, I'll use a product rule to solve it, but you could have also said, oh, well, that's equal to 8x to the 1/3 minus x to the 4/3. There you go. Taking a derivative of that, but we'll do a product rule.
It's fine.
You guys did a product rule about
Yes,
this?
Danny, I did a product rule.
Can we not do the product?
You don't have to do anything. This is America.
Can we?
So I don't even have to pay attention right
You don't have to pay tax.
The top way.
now.
You could have, sure. Oh, you want me to do it that way too?
Like this is one.
But I'm on a roll here.
Yo, just do it this way.
This way,
You don't
please.
have to, but there's consequences.
If you go to jail, people's tax.
Okay, let's see.
People don't pay for tax.
This is a sum, and we don't want a sum, we want a product because the product will allow us to use the zero product rule. There's no zero sum rule. So I'm going to factor out an x to the what? Good, negative 2/3. So that's going to leave me a negative x. Whoa. I don't know why that just happened. Everybody see where the negative x came from? Negative 1 there, x to the 1/3, factoring out negative 2/3 gives you x. That's why you want to do that. This whole thing's out in front there, so plus 8/3 minus 1/3 x. I distributed it after I got rid of the x to the 2/3, which is x to the negative 2/3 times negative 4/3 x plus 8/3. How are we doing so far? Good. What next? Huh?
How come you're taking negative 2/3 out of 1/3?
Remember when you factor out, it's the same thing as dividing. So I'm doing x to the 1/3 divided by x to the negative 2/3. And when you divide that, you subtract. So it's 1/3 minus negative 2/3, which leaves me with just 1. What do I do next? Cry? Is that what somebody said? No crying yet. Go.
Can you factor out 4 things?
You could, but I'm not going to. I'm feeling saucy. I'm going to leave it in there.
Set it equal to 0.
What's it?
The whole thing.
Yeah, set the whole thing equal to 0. This is 0 when? When x equals 0. And this one? 2. Oh, nice, pretty critical numbers. Hot diggity.
That's fancy.
Notice that x is raised to the negative 2/3 power. So this might help us a little bit later on, but we're actually looking at this. So 0 doesn't make that derivative equal to 0, it makes it undefined, which is completely irrelevant as long as we remember to include it. Okay, got my critical numbers. What do I do next?
Test points.
Is that what it is?
Yeah, test
Number
points.
line.
Number line. What number line is this we're doing?
First derivative.
F prime number line. Put the numbers on the number line in the correct numerical order.
Can we learn about number order?
Yes, we can. I'll go get some of those 3rd grade number lines that you used to tape on your desk so you could count left and right when you're adding and subtracting. Yeah. I'll put them on the desk. You'll have them for tomorrow.
Should get some averages.
Jack, what number would you like to test to the left of 0?
Negative 5.
Excellent. If I put in negative 5, well, first of all, oh, Jack, what can you tell me about the value of that puppy,
It's going to be.
if you prefer that puppy?
It's going to be positive.
Always positive, right? Because it's a squared term. So this is always going to be positive. It doesn't matter what else we put in there. So that's easy. Now we just got to deal with this. If I put in negative 5 here, will I get a positive or a negative value?
Positive.
Positive. Positive times a positive is?
Positive.
Hot diggity. Now for the rookies in the group, you might say, well, that's going to go positive, negative, positive. And you would be mistaken. What, Jack, what would be a good number to put in there between 0 and 2?
1.
1 would be great. If I put in 1 here, is it positive or negative?
Negative. Positive.
Positive. Ooh, tricky. That's for you, Noah. What number would you like to put to the right of 2? Get kind of crazy here.
You know, I'll go 6.
So,
6. Wow.
that's-
I know. It's
I don't know if I was ready for that. Positive or negative?
negative.
Negative.
Put 3.
All right, Jack, what does that tell you about, let's start with 2.
It's relative max.
Give me the sentence.
At or hold on. There's a relative max at the point x equals 2 because the derivative of the function is going from larger or positive to negative.
Good. Well done. What about 0, Jack? What happens at 0?
No relative max.
Yeah,
when it-
keine Ahnung. Keine Ahnung, German for I have no idea.
Yeah. See.
Yeah, see.
In Spanish.
So you switch to Spanish
Yeah,
too.
no,
Yeah. Yeah, ich weiß es nicht. Yeah, I don't know.
Do you know German?
Yeah.
Do you know all German?
No, I haven't met the whole country.
You
Couple of them every once in a while, but I gotta get out more, you know.
Have you met every
fluent
German?
Yeah, I've met every German in the world.
Are you fluent or no?
Am I what?
Fluent.
No.
9.
9.
Are you conversational?
Mine.
Depends on who I'm talking to.
With us.
Probably with Jack I am.
Yeah.
So a native speaker?
No. I'd get laughed out of the room. Okay, so I'm still intrigued by 0. You don't have any clue?
No idea.
Okay, let's graph it. Pull out your calculators, graph the original function, see what it looks like, see if you can get an explanation as to why 0 is a critical number, but why it's not a max or a min. Question, sir?
Isn't asymptote?
No. Because in the original function, I can put 0 in there. I get 0. It does pass through the point 0, 0.
It's a jump.
It's not a jump.
Every time I try to grab something, it says like window.
What?
Like,
Wait,
so what do I
it grabbed it and then just got really mad and said, no, it can't grab it.
Your x min is bigger than your x max.
Would be undefined.
Well,
Or the tangent line.
okay, you gotta be more specific.
The tangent line at 0 would be undefined because it'd be like straight vertical.
Correct.
Do you have to say that though in your answer? Or?
No, because it's neither a max nor a min. We don't consider it an extrema. I'm just making casual conversation, just math talk, Bunch of friends sitting around talking about math. I thought I'd fire off like, hey, what's going on at 0, guys?
It's like when you meet somebody for the first time, you're just
Yeah.
looking for that.
Hey, how you doing? Nice to meet you. I'm Mike. Nice to meet you, Bill. Yeah, what's going on at 0, Bill? That kind of thing. Water cooler talk. Well said, Will.
It actually scared
Look something like that.
Yeah.
Yeah.
Maybe actually a little more scrunched in there. So this is, like we said, actually that's not a very good picture. It would be something more like that.
Yeah.
Okay.
Alex,
No, yeah,
right
totally.
here.
Absolutely.
Yes.
Still a function because it only goes vertical at that one particular point. We'll learn more about that one particular point later on when we get into the second derivative funness. But for now, we just stop there. Eventually, by the end of the chapter, what we're going to be able to do is use all our calc information, our vast stores of calculus knowledge, and we're going to be able to put together a really nice picture, without using your calculator, of a weird function like this. Because think about what we already know. We already know where that point is, because that's the max that Jack found. We could find the y value there by putting 2 into the original function. We know that something strange is going to happen at 0, and then I've got some other tools for you to use later on that's going to allow us to get a really nice picture of that graph without actually having to use a calculator or plot points. Okay? Questions? So really all we're doing is adding one sentence today, which becomes the first derivative test. And we also, well, 2 things. We also added an explanation of why off that first derivative number line we know that those numbers are maxes and mins based on increasing, decreasing, or positive and negative values for the derivatives. Okay? Great. Just great. Dug this out of my picture files. This was a cake that somebody brought in for Treat Tuesday a couple of years ago. It is a, in case you can't tell, that is a unit circle cake. Just wanted to throw that out there,
What?
Just saying, unit circle cake made by hand.
Alright, Maddie.